In non-aqueous titration, the concept of the leveling effect is somewhat different from that in aqueous solutions. In this context, the leveling effect refers to the phenomenon where the strengths of acids and bases are essentially leveled or equalized due to the nature of the non-aqueous solvent used. In non-aqueous solvents, the ability of solvents to dissociate ions can vary, and some solvents may not support the complete dissociation of certain strong acids or bases. As a result, even strong acids and bases may exhibit behavior similar to that of weak acids and bases in these non-aqueous solvents. This leveling effect can affect the accuracy and precision of titrations, as the distinction between strong and weak acids or bases may not be as pronounced as it is in aqueous solutions. Let's consider an example of the leveling effect in non-aqueous titration. Example: titrating a strong acid with a strong base in a non-aqueous solvent. Suppose we are conducting a titration of a strong acid, such as perchloric acid, HClO4, with a strong base, such as sodium hydroxide, NaOH, in a non-aqueous solvent, for instance, acetic acid. In the absence of the leveling effect, one would expect a complete dissociation of both the strong acid and the strong base into their respective ions, H+ and ClO4 for HClO4, and Na+ and OH for NaOH. However, in non-aqueous solvents, the solvation of ions can limit their complete dissociation, leading to a leveling effect. In this scenario, the leveling effect may cause the perchloric acid and sodium hydroxide to exhibit behavior similar to that of weaker acids and bases in the non-aqueous solvent, affecting the rate of reaction and the observed equivalence point. As a result, the titration curve may not show as sharp a change in pH as would be expected in the absence of the leveling effect. Some examples of non-aqueous solvents that can limit the dissociation of ions include acetic acid. Acetic acid is a common non-aqueous solvent that can limit the dissociation of ions due to its ability to solvate both cations and anions. Dimethyl sulfoxide, DMSO, is a highly polar aprotic solvent that can limit the dissociation of ions, particularly in the case of strong acids and bases. Acetonitrile. Acetonitrile is another non-aqueous solvent commonly used in non-aqueous titrations, where it can affect the dissociation of ions and exhibit the leveling effect. Ethanol. Ethanol is a polar solvent that can limit the dissociation of ions, making it suitable for non-aqueous titrations involving certain strong acids and bases. Tetrahydrofuran, THF, is a commonly used non-aqueous solvent that can limit the dissociation of ions, particularly in the context of non-aqueous titrations.